Hello there, everyone at home. Let's check out our warm-up today. Here it is. So use the triangle below along with the triangle angle sum theorem to find the measure of angle 3. Let's see if I can get a little bit of help with that. Luke, what would the measure of angle 3 be here? Be 57 degrees. How did you get that? Yep, 42 plus 81, which is 123. 180, yeah, you do a... Yep, perfect, beautiful. How many of us were able to get, what was it 57? Yeah, cool. Excellent, very good. All right, guys, so it is the 114th day of school. Did you guys know that 114 is the smallest whole number that has not yet been represented as a sum of 3 cubes? Let me explain. If I can add 3 cubes together, like if I do 2 cubed, maybe, let's see here. There we go. If I do 2 cubed plus negative 5 cubed plus 6 cubed, I get 99. So that's how I can write 99 as the sum of 3 cubes. 114 is the smallest whole number that we have not yet found the 3 cubes that add up to it. Not counting numbers of the form 9k plus 4. Because it turns out, and I can only imagine what the proof to this must look like, that if you put in k, any number for k, just give me a number. 24. I don't want to do 24. 9, 1's fine, 1's fine. So then I do 9 times 1 plus 4. 9 times 1 is 9. 9 plus 4 is 13. So I cannot write 13 as a sum of 3 cubes. But 114 is not one of those, so theoretically we should be able to, but no one's been able to find it or prove that we can't. How many of us are like, I know what I'm doing tonight? Yeah, there you go. Hey, if you find it, you'll be famous. And as we've already discussed here in class, it's Scouse Appreciation Day. If you weren't here, I highly recommend you check out your time card. There's a link to that video right there. Guys, was that video worth watching? Yeah, it was cool. It was cool. Okay, what's our first essential question? And I would love to get that from Andrew. Yeah. Let's see here. Where did that go? What about variable expressions? With transversals and triangles. Okay. Let's see here, guys. So, let's see. Not this one. Not this one. Okay, here we go. All right. Let's see here. So, Jeopardy, diseases. The alliterative common this isn't actually a single virus, but rather a huge group of unknowable rhinoviruses. That is indeed the cold. The cold. Basically, we call anything that's like, there's a gazillion diseases that do this, and they're no big deal, and we just get over them. They're all colds. And then that is Frankenstein. What do I say? Frankenstein. Frankenstein. Yeah, perfect. Okay, underneath all this, got a pencil? So someone did point out, and today's title, by the way, is Angles and Variables Again. Because we already did that with a lot of things. We already did that with like complementary, supplementary, vertical angles. Now we're bringing it into the 8th grade angle land. So yes, that is Frankenstein's monster. You're right, Stella. But remember, Pictionary, I'm just trying to get you to say the word. So when someone says Frankenstein's monster, they had to say Frankenstein, so I still got it. Yeah, perfect. So excellent. All right, so let's start with a pair of parallel lines. And we'll show that they're parallel by putting a few arrows on them. Let's do 2 this time. And we're going to cut them with a transversal. Now, what I'm going to tell you guys is that this value right here, is where. Okay, let me make sure. I'm going to grab my. I'm see if I can find my notes here because I don't want to mess this up for you. Is it under 7/8 compacted? Hang on. Hang on. I teach you guys in a slightly different order than the. Wait a minute. Aha. I think I found it. I think I got it. Okay, there we go. Whew. All right, here we go. So we're going to say that this R-E smiley. Okay, that this angle right here is 18R minus 2 degrees. And that this angle here is 78 minus, or excuse me, plus 2R degrees. So I'm going to tell you right now that I have given you enough information to tell me what R is and the measure of all these other angles. So when I say teach, I want you to say, okay, how can I use this picture to find out what R is, and how can I use that to find the measure of all the missing angles? Give it a try and teach. What's up, Jack? What do you need? Oh, perfect. Here, take it to your seat and then fill it out there so then you can talk about this while you're getting it all logged in. Check each other, see what's going on. Yes, Jacob. Uh-huh. Oh, I love Cockney rhyming slang. Hold on, like apples? Yep, apples are stairs. And then let's see here. Oh, I'm gonna go take a butcher's. I'm gonna go take a butcher's at what's going on over there. Mm-hmm. Which ones do you know? I love Cockney rhyming slang. That's okay. I got to tell you, when I learned about Cockney rhyming slang, I desperately tried to find a book where the characters speak in it, and I never could. I desperately want to know it, though. Like, I think it would be so fun. It would be so fun. You know that we do that at, just like Mr. McGowan and I do that for fun. Like, we try to come up with ones, like, on our own, because we don't know them. We don't know them. Okay. Oh, and also, Jacob, I gotta say, it's gotta be annoying that anytime something about the UK comes up and it's something you don't know, that people are like, "What? You didn't know that?" Like if someone shows up, like if someone lived over there in the UK and they were like, "All right, guys, what's the capital of Michigan?" And everyone looks over at me, I'd be like, "I don't know, Detroit." Like, all right, everybody, come on up in 5, 4, 3, 2, 1. Okay. Hey, you guys did an awesome job talking to each other about that, and I think you guys do deserve a point. So, really, what this comes down to, guys, is that we're trying to figure out what relationship these two angles have. So, how are these two angles related, Solomon? How are these two angles related? Correct. Which means that they must be what? Ah, careful. Watch this. Guys, This angle has to be the same as this angle because when you have corresponding angles on parallel lines, they're congruent, right? But that means that this angle has to be the same as this angle. So it turns out that these two angles, they don't add up to 180, they are equal. They are equal. These two angles are equal. And in fact, I'll actually see students who do that where they're like, okay, I got to remember that these are the same, and I got to remember that these are the same. And that can really help you decide if they add up to 180 or if they are equal to each other. So since they're equal to each other, we can set the two equations equal. 78 plus 2r equals 18r minus 2, whatever that happens to be. Let's see here if I can get a little bit of help. Let's see if I can get a little help from Keenan. If this is our equation, what's going to be our first step? Love it. That's going to give me 78 equals, looks like 16r minus 2. And what am I going to do to solve that two-step equation? Add 2 to both sides. I get 80 equals 16r. And then? Which gets me what? R equals 5. Beautiful. Now, how the heck am I supposed to... Oh, no, so we got a question. Oh, no, okay, okay. Keenan, how am I supposed to... Or you know what, Keenan? I bugged you enough. Thank you so much. That was perfect. Now, how am I supposed to use that to find out what R is? Let's see if I can get a little bit of help. And that one's going to come from... Just drawing empty seats. There we go. Gabriel, what can I do with that R equals 5 to find the actual measures of the angles? Perfect. Yeah. Just take this R and replace it with a times 5. 18 times 5 is 50 is 90. 90 minus 2 is 88, which means this was 88 degrees. And so is this. That's 88 to the 8th. I don't want that. 88 degrees. So is this. So is this. What about the other ones? I didn't have any information about the other ones. How am I going to find the measures of those angles? Let me see if I can get a little bit of help. That's going to come from Frankie. How am I going to find the measure of these angles? Yeah. 92 degrees, right? That's fine. How many of us were able to get 92 degrees for that? See that? Okay. Beautiful. I got one more of these before we move on to triangles. Got a pencil? Okay, here it comes. Let's see here. There you are. Okay. Draw this. And then two parallel lines going through it like this. I need an animal with 1, 2, 3, 4, 5, 6, 7, 8 letters in its name, no repeated letters. Ooh, does that work? Oh, I'm going to do that in a minute. Ostrich. Oh, we're off. You know what it is? It's a bostrich. Bostrich. It's a bostrich. So another way I could tell you guys this is that I could tell you that OT, and I'll put a little line over it, that's saying line OT is parallel to line RC. That's another way I could tell you that they're parallel. So I'm going to tell you right there. And I'm also going to tell you that the measure of angle 1, the measure of angle OSB is equal to 4y plus 18 degrees and the measure of angle HIC is equal to 2y minus 63 degrees. So the question is, are these angles congruent, or do they add up to 180 and then use that to find out what y is and what all the remaining angles are? Teach, teach! What, the angle or the variable? Now, plug that back in. See if you get a negative angle, because a negative variable is not necessarily bad news, but a negative angle is for now. Negative angles don't become a thing until quite a bit later. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Okay. Hopefully I didn't mess this up. Maybe I messed this up. Hang on. I think I might have messed this up. So these two should be equal, right? And that's 2y minus 63. Now we start solving it. We subtract 2y from both sides. Oh yeah, this isn't good news. 2y equal a plus 18 equals negative 63. How has this lived in my notes for so long? Oh boy, and then you minus 18 here. Uh-oh. Excuse me. 2y equals negative 81. Now guys, I'll tell you right now, we're not doomed yet. Because that's negative 40.5. Because I'll tell you right now, your variables can be negative, and that's okay. But if your values here are negative, your angles are negative, that's going to be a problem, which I think is going to happen, because 4 times negative 40.5, we got to do this guy. Let's see here. TI SmartView, TM emulator software for the TI-30X/TI-34 multi-FIP. TM calculators, text instruments. That's all we got. We're still loading. There's a white one. There's a gray one. There's a blue one, too. The blue one's design looks very different than the other two. I don't think 2 rhymes with 2, even though they're different. I don't think you're allowed to do that. I wish this song was over. Hey, hey, hey. I wish this song was over. I wish this thing would load so I could stop singing this song. I don't want to sing this song. Okay, there we go. All right, so... I know. What the? Why is this happening? Boo. Boo, it's just wasting time for no reason. There we go. Okay, so if we have, let's see here. So 2 times negative 40.5 minus 63, yeah, you definitely get something that's no good. I wonder if, you know what, I wonder if, because I was hoping that I thought that in my memory this problem was, I wonder, guys, does it work if we change that to the measure of angle SIC? Can we try that? I don't think it will be. I think, let's try this. Honestly, I have no idea if this is going to work because I wrote this a long time ago. But what if we make that, instead of HIC, what if we make it SIC? So it's this angle here is 2y minus 63 degrees. And this angle here is 4y plus 18. Do you think that ancient Mr. Petersen in his late 20s meant that? Let's find out. Let's see if that's what he meant. Let's find out together. Teach, teach. I think that's what he did mean. I should change that. Maybe, do you think that's what I don't, he wasn't that smart. That seems, you know what I'm going to do? I'm going to do this. I'm going to say, I'm going to cross out the 7, and then I'm going to put the 6. And so that way I can decide if this was a good learning move or not. Did that turn out better? Good. You do? That's no good. Then that's not what I meant. Do we really? No, it shouldn't be a negative number that time. That time it shouldn't be a negative number. Yay! I wonder, was that a good learning experience? I think it might have been. I think it actually might have been better that way. Could that be what I have meant? I should have left myself a note. Okay, everybody. In the interest of time, let's keep this going in 5, 4, 3, 2, 1. So now that we're looking at this, guys, these angles are not congruent. Andre, what are these angles? What is the relationship between these angles after all? Yeah, you definitely will, as long as these are parallel, which is given to us. So we're just going to set it up. 1 plus the other is equal to 180. And then we can combine like terms. So 4y plus 2y is 6y. 18 minus 63 is negative 65? No, negative 45. Sorry. I was thinking 95, 93. Equals 180. And now we can solve this as a two-step equation, and life will be good and green again. We add 45 to both sides. 6y equals 125. Divide both sides. Oh, sorry, 225. Goodness gracious, can you tell I'm feeling a little rushed today? Yeah, I know. Oh, thank you. And then so we're going to divide both sides by 6. And does somebody have that? 37.5. Oh, so hold on. Right, because it's already got the degrees in there right there. So now I can feed that back into either one. 2 times 37.5. And that's minus 63 is 12. So this one was 12 degrees, which means all the other ones have to be 168 degrees. How many of us were able to get that or see how we got that and aren't too concerned? Do you guys feel like you can manage? Excellent. Here comes the next one. Got a pencil? Okay, we got this one, and then we have the worst case scenario. But this is not the worst case scenario. Draw a triangle. Wrap. Pra. Par. Or pa. All right, guys, here we go. Can I get you in 5, 4, 3, 2, 1? This angle here is 2 minus q degrees. The measure of angle P is 2 minus q degrees. The measure of angle A is 15 minus 2q degrees. And the measure of angle R is negative 3q plus 64 degrees. I want to know what Q is. I want to know the measure of angle P, the measure of angle A, and the measure of angle R. How many of us feel like we know exactly what to do? Give it a try, and here we go. Teach! Take another minute, guys. Another minute. Two. I know, you can't trust Mr. Petersen from the past anymore. He messed up. That worked out. All right, I love it. Okay, guys, can I get you in 5, 4, 3, 2, 1? We don't seem to know a whole lot about this, but Jacob M. What do I know about these three angles? I know that they have to add up to 180 degrees. So if I set up an equation, 2 minus q plus 15 minus 2q plus a negative 3q, which is really just a minus 3q. So minus 3q plus 64, whatever that is equal to 180. 2 plus 15 plus 64, 17, 74, 81. Minus a q minus 2q minus 3q is minus 6q's equals 180. So we take away 81 from both sides, which means negative 6q equals 99. Divide both sides by negative 6. Do you happen to have that, Jacob? Okay, negative 16.5. Hang on, my computer's freaking out. Negative 16.5. Now, guys, don't be scared by the negative variable, because as long as our angles come out positive, we're in the clear. So if we go in here, let's see, angle, I like 2 minus negative 16.5. 2 minus negative 16.5, and that's 18.5 degrees for angle P. How many of us got 18.5 degrees for angle P? Great. And then let's see, 15 minus 2 times 15 minus, let's talk about that in just a second. 15 minus 2 times negative 16.5. That's angle, so that's 48 degrees over here for angle A. So William asks a really good question. Is angle A the same thing as angle PAR? And the answer is yes. And the reason I can say angle A on this one is because it's an enclosed triangle. It's the interior angle of a triangle. And we don't, when I talk about an angle, unless I'm very specific, I'm not talking about the reflex angle.
If you had like two angles together for like a parallelogram, you'd need that.
Yep,
right?
absolutely. And if I had like a tail coming here, right? Because there'd be an angle PAR and an angle PAT or whatever it was. And then, honestly, we can either put that in, negative 3 times negative 16.5 plus 64, or we can just say, well, 180 minus 18.5 for angle P minus 48 for angle A had better give me 113.5 degrees for angle R. As you can see, super not drawn to scale. Now, I have one last thing to show you guys, and we're not going to actually have time to finish it, but I want to at least bring it up and see if we can figure out how we're going to manage. This is your worst case scenario tomorrow. Or sorry, not tomorrow. On your skill check on Thursday. This is your worst case scenario. Are you ready to see the worst problem I can give you? I sure would. I sure would. You're not wrong. So we've got this triangle. It's got a tail. Here's what I'm going to tell you. The measure of this angle is 4m plus 10 degrees. The measure of this angle is 6m minus 86 degrees. And the measure of this angle is 5m plus 20 degrees. There is something that we brought up the other day that is become absolutely critical here. I don't know very much about this, but what do I know about it? What do I know about it, Andre? Right. If I add these two interior, non-adjacent angles together, I get the exterior angle on the other side. So my equation would be something like 4m plus 10 plus 6m minus 86 equals 5m plus 20. From there you could solve for m. From there you could find every single angle that you want. How many of us feel like if that's as bad as it gets, bring this on? Beautiful. There is a self-assessment. There's two of them actually. One for transversals, and the other one for triangles. We don't have time though, because you guys did win the scoreboard game. You guys did awesome today. Go ahead and put your calculators away. Head back to your assigned seat, and I will dismiss you with the bell.